Hi everyone, welcome back to my channel. Today's session is again another drop-in session, so if you have any specific questions that you want to go through, let me know in the comments. If there's any specific topic you've got a question on, let me know, and we'll just go through in order of who asks first, basically. So today's live is just a Q&A session. Tomorrow we can go through a past paper again. Mondays, Wednesdays, Thursdays at 7 o'clock I do Edexcel higher tier past papers, if that's relevant to you. And then today is just kind of like a very specific Q&A. So if you've got like one specific past paper question you wanted to ask about, if you've got a specific topic you wanted to ask about, then that's what we'll do. Transformations. So there's kind of two types of transformations. Do you mean the one where you have the shapes and it says maybe enlarge or rotate, reflect, that type of thing? Or is it the one, like actual graph transformations, where it's like a reflection, translation, but with, you know, with the equation of the graph? Which of the two were you wondering? I'm assuming you mean the one with the shapes on a grid. Yeah, that's what I was thinking. Okay. Right, we can start with that. Let me grab some questions for you. So finding centers of rotation, I guess when they say describe a single transformation, maybe that one where they have to mention what it is and also what's happened, isn't it? Something like that. Okay, this is quite a good one. Yeah. Okay. Just sort out my pen. There we go. Right, so in this particular case, they've actually, we've got a few more marks because they're asking us to work out a few different transformations and then we're going to describe what has happened. So for this one, I'm actually going to draw out what's happened here. We've got triangle P is reflected in the line y equals minus x to give triangle Q. And then once we've drawn triangle Q, I'm then going to see where triangle Q would be reflected in the line x is equal to minus 1 to give triangle R. So the first one's a little bit more complicated. Y equals minus x. That one is a little bit harder because it's a diagonal line. Now obviously you can figure out by just plotting two coordinates if you want and then joining them up. But hopefully you would also know the line positively, or if I get my straight line, for y equals x, positive, is just diagonally this way. That's the positive version, right? So y equals minus x is just the opposite. So you might also already just know that anyway. Because if you think about it, if y is equal to 6, then it would be x is minus 6. It would be the same coordinates, but negative, wouldn't it? So it's that. That's that line there. Maybe I'll put it in a dashed line, actually, so we can see that it's a reflection line. So first of all, we need to reflect it in this line, which is a diagonal, so a little bit harder, but normally what I do is I just plot out the points based on counting the squares. So as in, you can count diagonal squares if you want. I find that's a little bit harder, so I just go kind of across and up. So it's 1 to the right and then 1 up to this first corner. It's obviously not changing size. So then here, just think about it, is a diagonal mirror. It would go 1 down and it would be here, wouldn't it? If you try and imagine putting a mirror along that line. Okay, and then from there, plot out another one, and then the last one should be, you know, not so difficult. So maybe from the same point, 1, 2, let's see. That's across, so it's going to go down, isn't it? How many is that? 4. So 4 down, 1, 2, 3, 4. So here. And then this top point is going to flip over here, isn't it? So I just map that out. I'm just going to draw this kind of interim triangle, just so that I can then visualize it for my next one. So let's label that. What was that? That was Q. Just double check. Yeah, that looks like it's been reflected. Yeah. Okay, and then the next one, a bit easier, this one now, because it says it's been reflected in the line x is -1, but just be careful, it's actually a vertical line. You might think it's horizontal, it's actually this line here, isn't it? Because it doesn't matter where you are on this line, it was always x is -1. Would -y be the opposite way? It would be the same. It would be the same line, because if you think about it, well, if x is equal to -y, if x was 6, -y would be -6, wouldn't it? So it'd be the same line. Because the only other possible way it could be is the positive version, isn't it? Yeah. Okay, so then we're just going to reflect this one. This is a bit more straightforward, isn't it? Just straight across. It's obviously a distance of 2 from that reflection line. So this one's a bit more obvious. And then we can see how it's rotated. There. This one's R. Okay. Oh, that's, yeah. R. There we go. So just have a quick read of this, because do double check which one are they referring to, right? It's from the single transformation that maps triangle R to P. So we're going backwards like this. How would I go from R to P? So then obviously we're trying to figure out, we've got, is it a reflection? Is it an enlargement? Is it a rotation? Is it possibly a translation, like it's moved left or right, up and down? So in this case, well, so this one I'm thinking, this one looks, I would say, like a rotation, doesn't it? We're ignoring this triangle now. We don't need Q anymore, right? We don't need Q anymore. What we now need is from R to P. How do I get back from R to P? I would have suggested that that's a rotation, because it looks like it's kind of flipped 90 degrees, doesn't it? Yeah, exactly. When x is y, they're the same for each coordinate. So that's the positive, like this diagonal here, isn't it? This direction. And then if one of them is negative, then it's just the opposite way around, isn't it? So I think that's a rotation. What I would probably do is, you should be allowed tracing paper. Either they give it to you, or you might have to ask for the tracing paper. But I would just get some tracing paper, and then you can test it out if you want. So I would say that's a rotation. So let me write that down, rotation. Now we have to, obviously, as you mentioned, specify things about it. Yeah, exactly. We need to know the center of rotation. We also need to know how much is it rotated by. So that's what I'm saying. What I think I would do is use the tracing paper, because if you get your tracing paper, I know I don't have any digitally, I would get the tracing paper, obviously put it on top, draw, over triangle R, and then you could always stick your pen or your compass, whatever you want to use, in different coordinates and see which one does map it onto P. That's one way of figuring it out. If you have the tracing paper, they should give you tracing paper. If not, definitely ask for it. You could do that. Or what I was thinking is, it's kind of where the two reflections overlap, isn't it? In this particular case, you're not always having to reflect it first, right? Sometimes it's just directly describe it. But it's basically here, isn't it? Where they both overlap. But that doesn't necessarily work for all questions. Because you see, the distance or the difference is like 2 squares this way, isn't it? 2 squares this way. And now it's rotated to be the same amount of squares, 2 squares up. So I also think that that's a 90-degree rotation, isn't it? 90 degrees. So if it's 90 degrees, you do have to specify the direction as well. So this would be anti-clockwise, because I'm going from R. Clockwise. And then you would say the center, which is, what's that, -1, 1? But I think I would just test it out with my tracing paper, to be honest. Yeah. Yeah, that's why I don't know if you were doing Edexcel or not, but for people doing Edexcel, I think it's already come up, so I doubt that it would come up again. It seems unlikely. But for those of you who maybe did a different exam board, I don't know if it's come up yet. This is for higher, yeah. This is for higher tier. Yeah. Yeah, so if they don't always give you tracing paper at the, just automatically, what you can do is you can ask at the start of your exam for them to give it to you, even if you don't know if you need it yet or not. Just so you're not, because I've heard some people say they were waiting quite a long time for tracing paper, which is obviously quite bad in the exam. So you can always ask for the tracing paper just right at the start, and then just keep it on your table if you need it or not. But yeah, I think that's what I would do for this one. But generally for rotations, I'd probably just use the tracing paper and figure out where the center is from there. Sometimes you can kind of visualize it. Sometimes you might want to just test it out with the tracing paper. That would be my recommendation. I don't know if you had any questions about anything that wasn't a rotation, or if that was just the question, like mainly on rotations. Construction. It obviously could, but it's one of those topics that doesn't come up very often. Like, it's one of the fewer. Well, again, I'm speaking for Edexcel. I don't know in terms of other exam boards, but it doesn't really come up very often. I mean, it could always come up. Obviously I don't know what will come up and what won't. It could, but it's, I guess, more unlikely compared to other topics. Especially as we saw, obviously, in paper 1 for Edexcel Higher, you had fewer questions, which obviously then meant there were fewer topics that came up, which was odd. There's still a lot of topics, I think, that should have come up in paper 1 that would probably then be pushed onto paper 2 and paper 3. So yeah, I don't know. It's not very common that it comes up. Same with like bearings. That's not very common. There's certain topics that are not very common. The paper's not today. We're not doing a paper today. The paper is going to be tomorrow. You know how we did it before, Monday, Wednesday, Thursday, same routine, same schedule, 7 o'clock, we'll be doing papers 2 and papers 3. Yeah, vectors, I think they're definitely going to throw in there at some point, aren't they? 100%. I've got a video coming out tomorrow of the topics I think are, again, for Edexcel, that I think are more likely to come up. But the problem is it's quite a big list, because there's still quite a lot that hasn't come up yet, so that's the problem. I haven't really narrowed it down very much. But yeah, vectors I think is one that will come up. Circle theorems I think will obviously come up. Because cumulative frequency hasn't come up yet, I do think that will come up at some point. I don't think you got anything on indices either, did you? That was really odd, so that's probably going to come up in a different format. I don't know, it depends if they're just going completely off the structure this year. Yeah, iteration's definitely a calculator style question, isn't it? So if anything, that'll come up. Yeah. Let me see what else I thought was going to come up. I've made a list. I don't think you had any sine or, well, as in sin, cos, or tan, right? Did you have any trigonometry? Like even just basic trigonometry? I don't think there was any of that, was there? Because that must come up at some point, surely. Basic trig or Pythagoras, I'm thinking simultaneous equations hasn't come up yet, but that could obviously come up in any. Let me upload this so you can have a look. But this is from my video that will come out tomorrow. Let me just grab it. I think it's this one. Obviously a lot of volume and area. I haven't had any of that yet. Here we go. These are the ones that didn't come up in paper 1 that I think will therefore be pushed into paper 2 or paper 3. Obviously I don't know which, paper 2 or paper 3, it'll be one of those, I don't know which. So as we said, vectors, circle theorem, simultaneous equations in some format. That could obviously come up in a lot of different formats, but it will come up at some point. I think cumulative frequency and or box plots, it seems to come up every year, and because it didn't come up in paper 1, I do feel like it will come up again. paper 2 or paper 3. Some kind of basic trig, right? So SOHCAHTOA or obviously maybe Pythagoras. Volume and area, we haven't had any of that yet. Vectors, straight line graphs, nothing about straight line graphs. Didn't really have anything on algebraic fractions. Didn't really have anything on indices. And speed, distance, time comes up a lot. Yeah. I thought the one where you join up all the corners was enlargement, but I don't know. Maybe you have a specific method that I haven't seen before. This is the topic, calculated topics generally, and I'm not saying this is specifically paper 2 because from what I've seen, paper 2 and paper 3 are just kind of a mixture. So it's quite hard to determine what will be just paper 2 and what will be just paper 3, right? So I can't really specify beyond that. That's why I've just said calculated topics in general, because I don't really know. But error intervals comes up a lot, which is a nice 2-mark question. Obviously ratio, I know it came up a lot in paper 1, but ratio just comes up constantly anyway, doesn't it? It will come up in multiple questions. Volume, I think volume obviously generally, but also with a context. So when they give you a real world kind of context, I think that tends to come up quite a lot. Some form of area, perimeter will probably come up quite a lot. I think maybe circle, sectors, that kind of thing is quite common. Product rule for counting seems to come up on paper 2 or paper 3. Obviously compound interest for sure is a calculated topic. But also just be aware that compound interest could be depreciation as well. So like a decreasing version, that's kind of included in the same topic. Density is mass over volume, that comes up quite a lot. You need to know the formula for that. Iteration, as you mentioned, upper and lower bounds, because sometimes they make them harder, don't they? There's quite a lot of decimals, so obviously that would be a calculator. Probably sine and cosine rule somehow, maybe one of them, maybe both. Or maybe the area of a triangle, the trig one. One of those will come up probably. Possibly 3D trig. That's not necessarily a guarantee, I don't think. That doesn't come up all the time, but obviously there's a possibility, isn't there? And we haven't seen any normal trig yet, so that might kind of be 2 in 1. Graph transformations, I don't think you've seen that. You've obviously seen transformations in terms of the shapes, but not in terms of graphs. You haven't seen completing the square yet. That's not necessarily just a calculated topic, but just because you haven't seen it yet, that's why I thought I'd write it down. I see a lot on paper 2 and paper 3, they have a lot of what I'd call coordinate problems. They're quite random, each of them, but maybe it's working out the distance between 2 points on a grid. Maybe it's, so that's when you'd use Pythagoras. Maybe it's finding a midpoint, some kind of coordinate problem, right? Obviously, I know probability, you had a really hard question in paper 1, but probability generally will just keep being asked, I think, just different questions. Expanding triple brackets tends to be paper 2, paper 3. And some, maybe mean from a frequency table or some kind of mean, maybe reversing the mean. That was kind of me trying to summarize it, right? Obviously, there's so much, right? There's still, I'm not saying that this is the only thing to revise, because I did have a lot of students who said, oh, I only revised certain topics for paper 1 and they didn't come up. Obviously don't do that, because you genuinely, none of us know what's going to come up. So you do need to try and have at least an idea of the whole syllabus, which I realize is a really big syllabus, but we do need to try and at least have the whole syllabus. You can obviously tick off some of the topics you saw in paper 1. So for example, histograms, I don't think they would repeat. What was the other one we were talking about? The transformations, I don't think they would repeat that. Do you know what I mean? There's some that are quite specific that I don't think they would repeat. So you could obviously tick off some of those, but even then there's still so much left. So to try not to narrow down, don't put all of your eggs in one basket and think, yeah, this is the only list I'm going to revise from. Like, that would be too risky. Just maybe if you're thinking, I want to have some kind of a bit more of a focus, then yeah, sure, use the list. But do try and make sure you're doing past papers, because at least with the past papers, you'll be seeing everything. Okay, let me have a look at the comments. Yeah, no, you haven't had bounds yet, or error intervals. The product rule for counting is kind of a fancy way. Some people call it combinations. When it says, oh, there are 5 starters and 10 main courses and 3 desserts, how many possible combinations could they choose? That type of question. That's what the official name of that is, product rule for counting, because when you just multiply them all together, and then counting, I guess, is just saying how many there are. So that's the official name. But yeah, that one's quite a nice topic. Is bearings a common topic? No, bearings is not common at all. Not to say it won't come up, but it's not common at all. It doesn't come up every year. It's one of those ones that doesn't come up every year. Yeah, draw a scale map. Yeah, because it kind of overlaps with that, doesn't it? The scale map is like another topic. Sometimes it overlaps with that. Yeah, bearings, you just have to make sure you're going clockwise from the north line, as they've said, from the north line, and then you'd be fine. Mean, median, and all that from a frequency table. Yeah, that's what I'm thinking might come up. Volume, surface area, exactly. Yeah. Volume and surface area hasn't come up at all yet, has it? So that's definitely going to show itself at some point. Yeah, we'll do mean from a frequency table. That one's quite nice, actually. Coordinate problems. Yeah, you can kind of figure out the coordinate problems, I feel like. If you fail paper 1, you just have to do better in paper 2 and paper 3, basically. You just have to, yeah, you just have to kind of figure out why you feel like you failed paper 1, what went wrong. See if you can do anything to fix that before paper 2 and paper 3. Yeah, histograms has already come up. I don't think that would come up again. Complex vectors, that's still obviously on the cards. Yeah, the papers are, you can try and predict it, but it's still risky. Like, it's still very unpredictable. They could literally do anything. So try not to put all your revision into like 1 or 2 things. That's obviously not like a super smart thing to do. So, okay, right. Mean from a frequency table, let's do that. That one's a really nice one because it's the same method every time. So if you can remember that, it's a super easy question. Mean questions. Let me grab a nice one. Let's see what we've got. It's always normally about 3 marks as well, which is a decent amount of marks to get for something that's, you know, not too difficult. Here, this is one example. You can see question 4, like, literally is at the start of the paper. So, pretty nice. Okay, so obviously the context will be different every time. The table gives information about the times taken in seconds by 18 students to run a race. So you know that the 18 is like the total, isn't it? So this is our frequency table, you can see, because obviously it says frequency on it, it's a table. And you'll have ranges on the left-hand side on the left column. So work out an estimate for the mean time. It's obviously an estimate because of these ranges. So what I tend to do, you can lay it out differently, but what I tend to do is put 2 more columns on. So 1 is the midpoint. So that's obviously the midpoint of these ranges. That's why we're making an estimate. So just find the midpoint. So that's obviously halfway between 7.5. If you're not sure how to find the midpoint, just by sometimes looking at it, you can do it quite easily. Sometimes the numbers are quite difficult. So if you want to find the midpoint, and this also relates to finding the midpoint of, you know, like a line, coordinates, that's a completely different topic, but the midpoint is still the midpoint. You can add the 2 numbers together. So for example, those 2, add them together and half them, like basically find the average of those 2 numbers, because you see how that would give you 15/2, which is the same as what I've written, 7.5. So if you're not sure how to find the midpoint just by looking at it, then you can do that method. And as I said, it also works for coordinates as well. So you can kind of, I feel like this one's not too difficult to visualize though. You can see 12.5, 17.5, and 22.5. So that's one column. The next column is then you do the frequency column multiplied by the midpoint column. So that basically these 2 columns multiplied together. So this is why I would suggest it's normally more likely to be a calculator question, isn't it? Sometimes you could do it yourself, but I think most of the time it has decimals. So what's that, 25? 35, I think, 35. Oh no, I was timesing it by 2. It's not times by 2, times by 7. 7 times 17.5, 122.5. 122.5, and then 8 times 22.5, 180. So once you've done that, so effectively here's your steps. Step 1, midpoint. Step 2, multiply them. Step 3 is then you add up this column here, the one you've just done. Add that all together. Because you know with mean, you obviously add them all up and then divide by how many there are. That's effectively what we're now doing. So I'm just going to add them all up. 122.5. Which gives me 335, I think. 300. Yeah, that looks right. Now the last thing, which I'll then come down here, this is step 4, is then the actual bit that you probably recognize as mean. Obviously you take that and divide by how many there are, which they did tell us in the question it was 18. If they don't tell you, obviously you need to add up the frequency column, but they told us, so I don't need to add it. And that obviously does give me a decimal. 18, what does it say? 3 significant figures, 18.6 to 3 significant figures. There we go. You can see that makes sense because most of the numbers are kind of weighted towards the last 2, aren't they? So that would make sense. So you just repeat that on any context, basically. Just repeat that same exact method. So as long as you memorize that, then it's pretty straightforward. I know you don't obviously need histograms anymore, but for anyone doing maybe a different exam board who might still have histograms, when they say work out the mean from a histogram, this is what I do. I just set up my own frequency table because, you know, with histograms you can work out, you obviously have the class width from the histogram, you can work out the frequency. So I just basically set up my own frequency table from the histogram, and then I just do this. So it's kind of 2 in 1 basically, but obviously I know you guys do it in Edexcel, you don't need to worry about that. You said median from a frequency table as well. That, when I see median from a frequency table, I think, isn't that the histograms question? Because it says work out the median or the upper or lower quartile from a histogram, but obviously you would normally use the table, wouldn't you? Well, at least I would use the frequency table. So I don't know if that's what you mean, but in which case it's already technically come up. Yeah, I don't know. Obviously median, upper quartile, lower quartile also comes up in cumulative frequency, but that's not really from the frequency table, is it? That's just from the graph. That could still come up. Median, upper quartile, lower quartile obviously could still come up on box plots, but again, that's not really from a frequency table. You don't tend to have a frequency table for that. So I don't know if that kind of covers it. They could ask you median from a list of numbers, like when they actually list it out, but then you just kind of cross them all off, right, until you get to the middle, so that's fairly straightforward. Trying to think of what else median would come up in. Maybe stem and leaf diagrams, but that's another topic that's very rare to come up, stem and leaf. Doesn't always come up. But again, that's kind of just a list of numbers, isn't it? And you just find the middle one. So, yeah, I think this is the main thing. The mean version is the main thing for mean. That could still come up now. And there's quite a few past paper ones that you can kind of figure out. I don't know if you wanted to look at the reversing the mean, because I wrote down mean from frequency table on my list, but obviously it could come up. I think mean would just come up in some format, so it could be from a table like this. It could be what I'd call reversing the mean. And then we can do a bit of vectors after that if you want. Conversion between currencies. Yeah, I think that would definitely come up, like some kind of conversion, whether it's currencies, whether it's like, you know, when it's like pounds and then kilos as in weight. Sometimes that comes up, that kind of conversion, isn't it? That would be paper 2. Area of frustum, compound shapes, and volume. Yeah, I feel like volume generally will come up, right? But we just don't know what shape it will be. But I think volume generally is going to come up, isn't it? Okay. Oh, let me see. The complex vectors one I do have videos on. It's just because obviously every Q&A I get asked vectors, so I try not to repeat it too much. So I do have videos on vectors that you can go back to. I've got quite a few actually. One of them being the hardest Edexcel vectors questions. You could have a look at that. That would be like the hardest ones. That's probably the best thing to look at. Let's see. Conversion between currencies. Yeah, that's pretty. You either multiply or divide for that. You just have to kind of figure it out. They'll obviously give you the conversion number, right? You don't have to memorize any numbers. And then volume. We'll do a quick conversions one and then we'll move on to volume, because I think volume's a much bigger topic, isn't it? Volume and or surface area, really. Well, yeah, you can see this is literally question 2, which means it's also technically foundation tier, because the first few questions of higher are normally the final few questions of foundation. So something like this, they've given us 2 conversions in one though. That's, I guess, quite common. So in London, 1 litre of petrol costs 108.9p. In New York, 1 US gallon of petrol costs $2.83. So they've obviously given you the conversions. You don't need to memorize those. In which city is petrol better value for money, London or New York? Now, you've got to obviously convert them both to the same currency and to the same, what's that, like, volume, litres, measurement. It doesn't matter which way you convert it, but as long as you do just have them both so you can compare them. So you might convert it differently to how I might convert it, but as long as we end up with the same answer at the end in terms of who we're going to choose, that's fine. So let's see, how would I probably think to convert it? Well, the money bit's probably easiest, isn't it? You could convert the pounds into dollars if you wanted. Obviously, make sure you convert this then also into pounds, right? So that's £1, 0.89. That's pounds. So converting it into dollars, if you're working with, I'm going to rewrite this conversion here, exchange rate. Do you see how I'm working with the side that it was based in? When I say based in, it's the one that's £1, or in the top one, it's the US gallon is the one it's based in, isn't it? 1 US gallon. If you're working on that side, you multiply, right? So I'm going to multiply this by the 1.46, which, let me grab my calculator. There we go. .4. Okay, and I'd probably write down all of those decimals. Because obviously, logically, the number of pounds, if I convert it into US dollars, is going to be a bigger number, isn't it? It's going to be a bigger number. So 1.58994. 1.58994. Okay. So that's how much. Oh, in dollars. That's how much 1 litre of petrol costs. Right, so we've got the same dollars. We also now need, therefore, to have the same quantity in terms of the volume type, right? So in terms of the liquid. So you can convert them both to litres, or you can convert them both to US gallons. That's up to you. So they've got 1 US gallon is $2.83. I've got 1 litre. So I might convert this into US gallons as well based on, let's do that. So I'm going to rewrite that one. You don't have to rewrite it. I'm just showing you, if it, just kind of writing it out, over explaining it. 3.785. Do you see how now I'm working with the side that it's not based in? It's not based in US, in litres, it's based in US gallons. So if you're working kind of in that sense, you're going to divide. So you're either going to multiply or divide. You just have to figure out which, basically. So in this case, I'm going to divide it. So 1 litre divided by 3.785. Where's my calculator? As I said, you might do it differently to me, that's fine. 0.2642. And that's in gallons now, isn't it? So we've got 1 US gallon, they said was $2.83. I've now got 2 gallons was 150, wasn't it? So you could compare from there. You could make it both into 1 gallon. You might have made them both into 1 litre. You might have made them both into like $1 or £1. Doesn't really matter. I can see from that if I would obviously probably multiply this one by just under 4. It's going to be cheaper in New York. You might have compared it differently, right? So that's up to you. But I can see from there that it's going to be cheaper in New York. Because I know that I would have to probably multiply that one by a little bit less than 4. And if you multiply £1 $1 60 by 4, it's going to be way more than $2.80, isn't it? So yeah. So yeah, just figure out, do I need to multiply, divide? That's basically all it is. It's, as you can see, it's only question 2. So they're normally kind of at the start of the paper, those ones. Yeah. Okay. Let's have a look at the frustrum specifically. Yeah, frustrum's quite a good one because it's kind of like, obviously, cones, basically, and they do like to ask about cones or spheres or hemispheres, don't they? So let me find cones, spheres, there we go. Okay, this one might be quite a good one because it's actually a really big question. It's got a frustrum, it's also got a hemisphere, and then it's relating to density as well. So this is probably the biggest type of question you could get. This is obviously a 5 marker, this one. 5 marks. Okay. So for cones and for spheres, they will give you the relevant formulas, as you can see on the actual question. So that also gives you a bit of a clue as to what to do, doesn't it? Because they said volume here. But obviously it's not giving you the specific formula for the frustrum or the specific formula for the hemisphere, so just be aware of that. They also tend to give you the diameter. I feel like they do that quite a lot. Obviously your formulas are based on the radius, so just be careful of those little details. So the diagram shows that the frustrum is made by removing a cone with height 3.2 centimeters from a solid cone with height 6.4 centimeters and base diameter 7.2 centimeters. So they've just chopped off this top cone, basically. It's just 2 cones. They've cut one off of the other one. The frustrum is joined to a solid hemisphere, so half of this sphere. Again, obviously has the same diameter, 7.2, to form the solid S shown. What was the actual question? Grab the actual question. Here, this was the actual question. You can actually see that. Yeah, you can just about see that. The density of the frustrum is 2.4 grams per centimeter cubed. The density of the hemisphere is 4.8 grams per centimeter cubed. We need to calculate the average density. So there's a lot going on here. We obviously also need to have our formula for density, mass, and volume, right? Because they won't give you that. So you do need to know that. I just like to use it as a formula triangle. Density is mass. Mass is the one that goes at the top over volume. Alright, so a lot going on here. Obviously you can see why we would probably therefore want the volume, because that's part of our density formula. So even if I wasn't sure what to do here, because they've given me the formulas for the volume of the sphere and the cone, I'd probably, I guess, start with that. Like, even if you didn't really know what to do, you might as well try and work out the volume of this shape, mightn't you? Even if you've got no idea why that's relevant to density, for example. So the volume of the frustrum is obviously the big cone minus the small cone. So there's quite a lot going on there. Let me get myself some more space. Or not. Not let me move it. Nope, just wants to zoom in. Okay, great. Just see if it'll let me move it over. I don't know why. Anyway, let's carry on. So volume of the frustrum. So volume of what I'd say is, I tend to label it just so I don't forget which one is which, because I've worked out so many volumes in this question. The volume of the big cone. So we've got our formula, 1/3 pi. Now, again, be careful, radius. So this is obviously 7.2 as the diameter. So you'd have to work out just the radius, which is 3.6. I tend to label it on just so I don't forget. So we've got 3.6 squared and then times by the height. Now the height of the big one is obviously these two added together. They also mentioned it here, didn't they? They said 6.4. So just make sure you're getting all these details right. Now obviously this was a calculator question, so I am going to just put it in my calculator. Times, make sure you know where pi is as well, things like that. Just all of these little details, make sure you know how to use your calculator properly. Okay. So obviously we're going to get loads of numbers. I'm going to write down a couple of those decimals. But ideally, I would want to keep them in my calculator, or you can use the storage function if you want. 86.858 ... Try not to round anything too soon when it's not, you know, the end of the question. So that's the volume of the big cone. I now need the volume of the small cone so that then I can subtract them. This is probably where we get a bit stuck. So it's a third pi. Now, what is the radius of the small cone? It's obviously not 3.6, is it? It's there. Smaller, isn't it? This is the bit that kind of throws people, but if you just memorize this, it's always the same. The cones are technically similar, aren't they? One is obviously just a bigger scale of the other. So you can use that scale to figure out what the smaller radius would be. So obviously what sides or what measurements do we have for both cones? Well, we know the small one is 3.2 high. We also know the big one is 6.4. So we could use that to find a scale factor, couldn't we? Scale factor. Yeah, I think because it's not super, it's just they want you to kind of have put 2 and 2 together, which is quite difficult to do. So the scale factor, you can divide it whichever way round you want. Normally I divide it. I normally do the big divided by the small. It doesn't really matter though. You divide it however you want. You can kind of see what the answer would be. You'll either get 2 or a half. It doesn't matter which one you get as long as you then apply it correctly. So what we're saying, I did it this way. The big cone is twice as big as the small cone. So the big radius is going to be twice as big as the small radius. So I'm just going to half that radius. So that should be 1.8, shouldn't it? Again, squared. The height of that one, again, just make sure you've got all the right numbers, is 3.2. Let me see if I can just store this number. Okay. Yeah, I'm going to store that for later. Now, obviously, I'm going to work out the small cone. I do have a video on Friday coming out about calculator tricks. So, things that you might find helpful. That'll be on Friday. 1.8 squared times 3.2. 10.857. Yeah. Now, obviously, then, for the frustrum, you just subtract them. It's not really more complicated than that. It's just literally taking them away. So that's why I wanted to keep my other number. So now because I stored my other number, I'm going to do that. I'm going to do where I stored it in A minus my answer, 76.00. Luckily, that's kind of a nicer number, isn't it? So about 76. Again, I might try and keep that number there for now. But so the frustrum, let's see where I've got space. Volume of the frustrum is basically 76, isn't it? I know it's got decimals, but it's pretty much 76. I'll just write that. So even if you weren't really sure what to do, that's the first bit you could do. Now, I guess unfortunately, that only gives you 1 mark, which I think is quite mean. That's only 1 mark for all of that. But if you weren't sure what to do, you could at least start with that, couldn't you? Now, obviously, then logically, then what we could then do is find the volume of the hemisphere. That's fairly straightforward, isn't it? Volume of the hemisphere. But again, be careful because we've been given a diameter, we've been given the formula for the whole sphere, so it's all these little details I need to remember. So 4/3 pi, now the radius as we said was 3.6, it's half of the 7.2 cubed, but I only want half of that because it's not a whole sphere. So I have to half the diameter to get the radius and half the whole formula to get the hemisphere. So let's store that one as well. Let's keep that one for later. Okay, so 4/3. Oh, no, 4/3. There we go. Times pi times 3.6 cubed. Here's my cube. Make sure you know where your cubes and your squares and all that type of thing are. That would be the whole sphere, but then obviously I'm going to half that. So 97.716 ... Okay, so that's my hemisphere. So then you could work out, I guess you could just add that together, couldn't you? Total mass, total volume, and then we'll find the total mass after this. So I could add that together. So take my answer here, add, I stored it under B, the other one. there. So 173.717 is the total volume. So that's one part of it, isn't it? There we go. Okay, so now we're moving on to the fact that we haven't really dealt with anything down here, have we? What we want to do to find the average density is we want the total mass divided by the total volume. We've got the total volume of the whole shape. I want to now know the total mass. So I'm going to use my density mass volume formula to find the mass, because obviously now I also have the volumes, don't I? So cross that out, density times volume, isn't it? Let me see if I've written too far across. Can you see that? Yeah, just about. Okay, maybe I'll put it in this little space here. So for the frustrum, I'll just put F. We want the mass would be density for the frustrum, which is 2.4, multiplied by its volume, which was the 76 ... one, wasn't it? Which I think I still stored. Yeah, it's 2.4. I have stored that one in B, I think. All right. No. That's too big, isn't it? 76 times 2 would be 150 or so. Obviously, make sure you remember which one is which. Oh no, that was fine. Yeah, I did get the right one. Make sure if you're storing it, if you're going to do that, make sure you remember which is which. Okay, so that's 182.4 ... 4. So that was in grams, wasn't it? And then the what was the other one called? The hemisphere mass, same thing, but obviously those other numbers. So we've got 4.8 multiplied by the volume, which is this one here, the 97, wasn't it? I don't think I stored that one actually, but that's fine. We'll just use the decimals I've written down. It will give you a slight range at the end, because obviously there were so many decimals to try and keep up with that, you know, not everyone would be keeping every single decimal, so that's fine. 97.716. So I've got 469-ish. Yeah, you can still see that. So then obviously we want total mass. No, I only do maths. I'm sorry, I don't do any science of any kind. Total mass, we can obviously just add those together. So the answer, I'll just copy that answer, I guess. And then 182.4, 651.4. Okay, we're almost there. We're almost there. All right, so the actual question was the density. So if I come back to my formula here, pick up this thing. If I'm finding density, to see how it's mass over volume. So pen over here. Density is the total mass, 651.4-ish, over the total volume, which I'll just write down all of that decimals there. So I'll just use my answer. Answer button. Try and use your answer button as much as you can, so you don't round anything if you can avoid it. So that was roughly that. So I've got, what do they say to round it to? They didn't say to round it, okay. I'd probably round that to 3 significant figures. Just looking at the decimals, it rounds quite nicely to 3.75, doesn't it? That's what I would round it to. 3.75. Density is grams per centimetre cubed. What was their range? Because they do give a possible range of answers, so let me just check the range. They've said as long as you got from somewhere between 3.7 and 3.8. So luckily I was bang on in the middle, but that's because I tried to not round anything, if you see what I'm saying. I know I didn't write down all the decimals, but I did try to keep all of the decimals as where possible in my calculator, so that my answer, you can see, was really, really accurate. But they do give us very small range of answers just because there are so many decimals. But yeah, that's a really big question, because obviously it is volume of frustrum, volume of a hemisphere, but also kind of similar shapes, and density, mass, and volume. So it's kind of all in one. But just so you can see, because I do think density is quite likely to come up as well, generally. Whether they come up together or whether it comes up separately, obviously there's different chances, but just to cover 2 in 1. Let's see. Yeah, for AQA, you will also get the volume of the sphere. Basically, if it's not a prism, so you see how a sphere and a cone and technically maybe a pyramid. Pyramids don't really come up, but the volume of those three things, because they're not prisms, they will give you the formulas for those. So yeah, but it will, again, it will be kind of pasted on the question if you see this. It's not necessarily on your formula sheet. Sometimes AQA I've seen, sometimes they give you the sphere like this one. Sometimes they'll give you an actual hemisphere formula if it's a hemisphere sometimes. So just double check for AQA which one they've given you. For Edexcel, they will always give you the sphere. Even if it's a hemisphere, they'll always just give you the sphere. So yeah. Yeah, I feel like that should have been 6 marks because you literally only got 1 mark for finding out the volume of the cone, and that was like 4 or 5 steps. Yeah. Okay, does anyone have kind of a last question, or do you want to do something else in terms of volume? That was probably one of the hardest questions, so hopefully anything from there is easier, basically, isn't it? But yeah, I've seen cones and spheres come up quite a lot. Yeah, no problem. Anyone have anything else before we finish this live? As I said, tomorrow we'll be starting paper 2 walkthroughs. Well, I'm going to do paper 2 and paper 3 at the same time because, as I said, you can't really tell when or how they're going to split the topics. So I'm going to go through both paper 2 and paper 3 for the next few weeks, leading up to, obviously, paper 2 and paper 3. So tomorrow we'll start with paper 2. I think we'll probably do the June 2023 paper 2 at 7 o'clock, but it's the higher tier one. Okay, well, I think I'm going to leave it there for today. I know it seems like you've got chemistry tomorrow or science tomorrow, so have some time to focus on that. But as I said, tomorrow, Wednesday, Friday are past paper walkthroughs if you're doing Edexcel higher tier. So thanks for joining me again today, guys, and I'll hopefully see you tomorrow.